Hello everyone, I am Rajiv Kumar and I welcome to all in my YouTube channel Info for EEE, and you are watching the playlist of Basic Electronics of Virtual Laboratory. In today's video, I will demonstrate the experiment of VI characteristics of diode circuit. Okay, and I already discussed the first experiment of this playlist, that is the Ohm's law and the application, in our previous videos. If you are not watching this video till now, so please go to the channel and watch the video. So let's begin. First of all, I just give you a quick review how to access the Basic Electronics Virtual Laboratory. So you have to visit the official website of Virtual Lab, that is the vlab.co.in. After that, you have to go to the broad area of Virtual Lab and click on the Electronics and Communication domain. Under the Electronics and Communication domain, there are the 14 to 15 labs, and you have to click on the Basic Electronics lab. And after that, this is the home page of the Basic Electronics Virtual Laboratory. Here you have to click on the list of experiment, and after that you have to go to the experiment number 5, that is the VI characteristics of diode circuit. So okay, so this is the experiment page of VI characteristics of diode circuit. Here a few tabs are available like theory, procedures, simulation, quiz, assignment and references. Okay, in the theory section, first we have check out the objective of this experiment. So in this experiment we have 4 objectives. First one is to explain the structure of PN junction diode. Second one, explain the function of PN junction diode. Third one, explain forward and reverse bias characteristics of silicon diode. And fourth one and last one is the explain forward and reverse bias characteristics of germanium diode. So in this video I will cover only 3 objectives, that is the structure and function of the PN junction diode and the forward and the reverse bias characteristics of silicon diode. So first of all, we have discussed the structure of the PN junction diode. So as you know, the PN junction diode is formed by a N-type or the P-type of semiconductor material, and I just refer the another website for the detailed explanation of PN junction diode. Here you can see that the N-type material and the P-type material. So in the N-type material, the majority of charge carrier electrons and the holes are in the minority charge carriers. But in the P-type materials, the holes are in the majority charge carrier, but electrons are the minority charge carriers. This is the circuit diagram where this is a circuit symbol of the circuit diode, and this is the real picture of the diode. So here you can see that the triangular part is so as a P-type semiconductor and the vertical line is so as the negative or N-type semiconductor. Okay, and the lead connected to the P-type semiconductor is called the anode, and the lead connected to the N-type semiconductor is called the cathode. Okay, so when we take together P-type and N-type semiconductor, so it's make a PN junction. Okay, or it develop a depletion layer near the PN junction. So this is the depletion layer near the PN junction. Here you can see that the P-type and the N-type semiconductor take together and it's make a PN junction and develop depletion layer. Okay, so basically diode are working in the two conditions. First one is the forward bias condition and second one is the reverse bias condition. So basically you can see that we have to connect the battery in a 2 way. First one is the anode is connected to the positive terminal of the battery and cathode is connected to the negative terminal of battery. Okay, in the reverse bias condition, we just reverse the battery terminal and anode is connected to the negative terminal of the battery and cathode is connected to the positive terminal of the battery. So now here just discuss the function of the PN junction diode. So basically when we connect the battery between the anode and cathode of the PN junction diode, so you can see that the holes in the P-type material are start moving towards the junctions, and in similar case the electron in the N-type material are start moving towards the junction, because positive terminal is connected to the anode and the positive charge of the diode is repel the holes and negative charge of the battery repel the electron. Okay, so that it will move towards the junction and diffuse to each other, so that the width of the depletion layer are reduced. Okay, so when we increase the battery voltage above a barrier voltage or above the knee voltage, so what is the barrier voltage? That voltage above that the diode start conducting. Okay, so when we increasing the battery voltage, so at level where the applied voltage is increasing the barrier voltage, the holes and electrons are jump together from one region to another region and diode start conducting. Okay, so in this case when we increase the battery voltage above the barrier voltage, diode will start conducting. Fine. In the reverse bias condition, we just connect the battery with the opposite terminal. Okay, but here you can see that when the positive terminal is connected to the negative terminal of the diode, so that you can see that the electron of the N-type material is towards moving to the terminal of the diode. Okay, in similar case the holes in the P-type semiconductor are moving towards the terminal of the diode, so that the width of the depletion layer is increasing and the diode is not conducting state. Okay, So when we applied the high voltage across the diode, or you can see that when we increasing the applied voltage above the breakdown voltage, okay, so high value of the current will flow from the diode and diode will damage. Okay, so this is the reverse bias condition and forward bias condition of the diode. Now we just check out the simulator of the forward bias condition and the reverse bias condition for the silicon diode. So all the detailed explanation of forward bias condition and the reverse bias condition are available in this theory section, so you can check out the theory section before going to the simulator page. So now I am just going to the simulator page. Here we have a 6 simulator. First one is the forward bias of silicon diodes and forward bias silicon diode draw circuit. Okay, the function of the both simulator are same, but in the first simulator circuit is already designed, but in the second simulator you have to first make a circuit, after that perform the experiment. Fine. And in similar case we have a 2 simulator for reverse bias for silicon diode, reverse bias silicon diode, and reverse bias silicon diode for draw circuit. So in the reverse bias condition 2 simulators are also available. In the first is circuit is already available, but in the second is you have to first make the circuit before performing the experiment. Fine. So let's start. So first of all I just perform the experiment from both the simulators simultaneously. So first of all we just choose the simulator number 1 that in the simulator circuit is already available. So firstly we have to choose the diode. Okay, so when we select any diode, the forward voltage, or you can say that the barrier voltage of that particular diode is available is 0.6 volt. Okay, so now we again change the diode circuit, that is the forward voltage is 0.62. So here I just select the diode IN40007. Okay, and after that firstly we have to set the resistance value. So in this case you have to change the resistance value from 100 ohm to 2000 ohm, or you can see that 100 ohm to 2 kilo ohm. Okay, so in this case I just take a resistance value is 100 ohm. Okay, and now you can vary the voltage 0.2 volt to 5 volt. Okay, so here firstly we set the voltage level at 0.2 volt, and now start moving the voltage level one by one and click on add to table. So as increasing the voltage level, okay, so you can see that when we increasing the voltage level, and the forward voltage and the forward current in the diode will be noted in the observation table. Okay, so here we just move the voltage level from 0.2 volt to 5 volt, and let's see what is the behavior of voltage and current in the diode circuit. Okay, so here you can see that the forward voltage is increasing manner, and also the forward current is also increasing manner, but here you can see that above the 0.6 volt current will start increasing. Okay, so now click on the plot. So here you can see that 0 to 0.6 volt current is very less, but above the 0.6 volt current is start increasing and diode is in conducting state. This is called the forward bias characteristics. Okay, now use this circuit to perform the experiment. Firstly we make a connections. So firstly we connect the battery to the resistor. After that we take a ammeter in the series and voltmeter in a parallel. Okay, and complete that circuit to make a circuit with the ground. Okay, after that click the IN4004, the forward voltage is 0.6 volt, a barrier voltage 0.6 volt, and repeat the same procedure. Set the resistance value from 100 ohm to 2000 ohm, or vary the DC voltage level 0.2 volt to 5 volt. Okay, so firstly we set the resistance value 100 ohm, and after that we vary the before varying the voltage you have to check out that you make a right connection or not. Okay, so firstly you have to check the connection. I just click on the check the connection, and here you can see that a message appear that is the right connection. Okay, so now vary the DC voltage. So firstly we start varying the DC voltage and take a readings at every increment of the voltage level from 0.2 volt to 5 volt. Okay, so here you see that what is the behavior of the current and voltage in the diode circuit. Okay, now click on the plot, and here you can see that this is a forward bias characteristic, and the diode start conducting above the 0.6 volt. So this is the forward bias characteristics of silicon diode. So here you can choose any diode to perform the experiment. This is a diode number, and the forward voltage corresponding to the diode number is different. So you have to choose any diode to perform the experiment. So now go to the reverse bias condition. So in the reverse bias condition, we have already available two simulators. In first simulator circuit is already available, but in the second simulator you have to make a circuit first. Okay, so firstly we choose the diode circuit IN4007. Okay, and set the resistance value 100 kilo ohm, and now vary the DC voltage 0.2 volt to 5 volt. Fine. So here you can see that when we choose the select IN4007, the breakdown voltage, reverse breakdown voltage 30 volt. So you can see that above the 30 volt diode will damage, or high value of the current will flow from the diode. Okay, so now start varying the DC voltage. Here you can see that when we start varying a DC voltage, the reverse voltage and the corresponding current in the diode circuit are available in the observation table. Okay, so here you can see that the reverse current in microampere means the value of the reverse current is very less, but when we increase the voltage level above the 30 volt, so you can see that high value of the current, that is a 75.5 microampere, will flow from the diode circuit. Okay, this is the characteristics of reverse bias condition. Here you can see that 0 to minus 30 volt current is almost 0. Okay, but after 30 volt current, a high current will flow from the diode circuit. So this is the reverse bias characteristic. Okay, now go to the next circuit. This firstly we make a connection. Firstly we connect the battery. After that we connect the ammeter and voltmeter across the diode circuit and make a connection to ground the circuit. And now check the connections. Okay, this is the right connections, and click on the diode in case IN4004 and the reverse breakdown voltage 30 volt. Okay, similar procedure we have to follow. Firstly we have to set the resistance value around 100 ohm and the DC voltage level vary from 0.2 volt to 5 volt. Fine. So now I am starting to vary the DC voltage and take a reading. So in this case I just take a random readings by increasing the voltage level from 0.2 volt to 5 volt, and you see what happened when we increasing the voltage level above the breakdown voltage, and before the breakdown voltage the value of the current also noted in the observation table. Okay, now click on the plot. So here this is the VI characteristics of diode circuit in reverse bias condition. Okay, so in this case I choose the silicon diode. Okay, so same procedure you will follow for the germanium diode. Okay, and the characteristic of germanium diode, you will be check out what is the difference between the silicon diode and the germanium diode. So this is enough for today. If you are liking this video, so please press the like button, and if you have any queries, so please ask in comment section, and share this video among your friend circle, so that the more number of the students can take a benefit from this type of the facility which is started by the government of India. Thank you very much. I will meet you in the next video.